SSIS learning module is going on, and in this video we will talk about the basic concepts related to the data warehouse. Data warehouse plays an important role in business intelligence solutions, so it is necessary to know the basic concepts of the data warehouse. So what is the data warehouse? Data warehouse is a central repository of integrated data from one or more heterogeneous sources that is used for analysis and reporting purpose. And data warehouse contains the current data as well as the historical data. The difference between the data warehouse and mart is that the data warehouse is related to the enterprise-wide business, while data mart focus on a particular part of that enterprise. For example, this is an enterprise and which have the departments like inventory, sales, production, purchase, accounts, cost management, and if we will concentrate only on some part of this enterprise like sales or production, then sales is one data mart, production is another data mart. So these are known as the data marts. So what are the data models available to design the data warehouse? Let's to talk about the data models. There are two popular models available in the markets to design the data warehouse. One is the Rolf Kimball and the other one is the Bill Enman model. Rolf Kimball's model is known as the dimensional model, and the Kimball used the bottom-up approach to design the data warehouse. Rolf Kimball suggests the dimensional model, which consists of the star schema or the snowflake schema. The star schema is structured where one there is a one fact table, and there are the related to this fact table are the dimensions tables. The fact table is normally contains the numeric data, and it represents the core business process. For example, if we are talking about the some trading enterprise where is they are selling their products, so this fact table the core process is the sale, and this has the numeric data related to the sale like the sales amount, the unit price, and tax amount, and the total amount, and it has the this foreign keys which are linked to the dimensions tables, and the dimension table is defined as it stores the details about the fact table process. It have the references that give the context of the fact tables. For example, this is the sales. What are the details for these sales? What is the product detail for these sales? We can find in the product dimension table, which have the details for the product, like what is the product color, what is the size, what is the tonality, what is the weight and units. Like all these details for these sales we can find out in the product dimension tables. And same like the if we want to know the salesperson, it we can find in the salesman dimensions table the details for the salesman. And the same like if we want to know about the customers details, we can find these details in the dim customer table. And same like in the dim date we can find out the dates and the years for these sales. So these is in the star schema. Basically, there is a fact table, and these fact tables are related to the dimensions table. And this is the same like there is the another schema is used to design the dimension model, that is the snowflake schema. Snowflake schema is basically same like the star schema. We can say this is the extension of the star schema. It is has normalized dimensions to avoid the some kind of the redundancy found in the star schema. Like if we will go again into the star schema, we see that this is the product dimension table which have the category and the subcategories table. If we will use the snowflake schema will suggest that make another dimension table for subcategories and the category tables which will relate to the product table. Same like if we have here the for the customer, the city and the country, the snowflake schema will suggest that make the separate dimensions for the city and the country tables. So it is the normalized form of the star schema. Like this is the dim product subcategory and the dim product category tables which are related to the products, and in the customer this city, province, country, are the separate tables, dimensions which are related to the customers. So customer is related with these dimensions tables. These are the basic two structures, two schemas used to design the dimension model. And dimension model have the facts and the dimensions tables. We can say these are the tables. This model is divided into the fact and dimensions. And Kimball model suggests that when the data will be extracted to the ETL process, first that there will it will the Kimball, according to the Kimball, the data mart first will be designed. So this approach first concentrate on the data marts. So this approach is easy to use, easy to design, and easy to implement, because it's focusing not only the whole enterprise, it's focusing only the some certain parts of the enterprise. So when the data mart will be ready, it's designed and it is ready to use. It will then the related user, the end user, can use this data mart for reporting and the analysis purpose. And then we can start with the another data mart, and this is step by step. According to the Kimball approach, all the data marts can be designed, or in the parallel we can design this one. So when these all the data marts will be finished, will be designed, will be implemented, then according to the Kimball approach, these data marts will be integrated to make our data warehouse. So in this approach, first the data marts will be designed, and then from these data marts the data warehouse will be designed. So this process will take less time and less cost, and easy to implement. But the drawback is that when the data will be extracted through the ETL process, it will be very complex to upload the data into the data marts. So this process is the complex process. And as per the Bill Enum approach, which is using the 3NF model, and the approach is known as the top-down approach. The Bill Enum 3NF model is recommending that the first we have to design the whole data warehouse. The enterprise related data warehouse first need to be designed. Well, the enterprise has the lot of the departments, so it will take the much time, and the cost will be more as compared to the Kimball model. And it will take maybe the months and the months, because the first we have to design the whole this data warehouse. Until the data warehouse will not be designed and implemented, the end user will not be able to use the this data warehouse for the analysis and reporting purpose. So it will take a lot of time. That is why the Kimball approach is more useful and the more popular for this analysis and reporting purposes. But the advantage of this data model, which is suggested by the Bill Enum, is that it's the long lasting and reliable data architecture. So these are the basic differences